Hello students, myself Ranjit Kumar, Assistant Professor in Computer Science Engineering Department, Maharaj University. Today we are going to discuss the topic that is knapsack problem using backtracking method. We can also solve the knapsack problem using different approaches like branch and bound method as well as the dynamic programming. Okay, now we will discuss the topic with the given example. Now we take the example. Suppose we take the weight. This is sorry. Weight we have taken 2, 3, and 4. Okay. According to weight, we select the profit. 1, 2, 5. As we considering the knapsack problem, so we have to accommodate the maximum weight they can be accommodated by knapsack, that is called M is equal to 6. Okay. Before defining the knapsack problem, we make which weight we have to select. We can be selected by the value either x in the form of we have selected, then it means to say x1 equal to 0. If we have not selected, if we have selected x1 equal to 1, if we are not selected, that x1 equal to 0. According to the selection and not selected, we have the options. Just according to option, we make the state space tree. Just make the state space tree of the problem. This is the state space tree. Firstly, we not selected any of the weight. At that cases, the weight of that node is 0 and the profit is 0 because we haven't selected any of the weight, and without selecting any of the weight, the profit will be the 0. Now make the selection according to that. This is the case. Take the value. First value we have selected, it means to say x1 equal to 1. If we have not selected, x1 equal to 0. Selection of the first weight gives the profit, that is 1. And we have selected the first weight, that means to say the weight of first weight is, that is called 2. Now we have not selected the weight, that is called x1 equal to 0. As the previous case, that means to say it is 0, 0. Okay. Again, we have selected the value. Second value we have selected x2 equal to 1 and x2 equal to 0. The weight of the second element, that is called 3. We add the value to the previous one, that is 2 plus 3, that is called 5. And the weight profit according to the weight, the selection of the weight number 1 and weight number 2, the total number of weight is, that is called, this is the case, this one we have selected the wrong value. We have selected the first weight and the second weight. The weight is total 355. Yeah, this is right. And according to the selection of the first and second weight, the total profit is 3. 1 plus 2, that is called 1 plus 2, that is 3. Now we have again selected the value. Not selected the second number of weight. The profit will be the same as it is earlier. We will continue the same process for the each number of the weight we have selected. X3. Sorry. That is x3 equal to 1 and x3 equal to 0. Okay. Now we have taken the third weight, that the weight is 4. After adding that weight, that is the total number of weight will be considered as the 5 plus 4, that is 9. 5 plus 4 is 9, and according to that weight, that 1 plus 2 plus 5, that is called total 8. The profit is 8. We will kill that node. Why? Because the knapsack weight is 6. They can't be accommodated, and as well if we are considering the node that is called 9, that is the total number of weight will be considered 9. That's why we cross that node and backtrack one earlier node, that is called previous node will be there. Okay, and now we are considering the third node. Now we are not considering that node. We consider this without considering the third weight. So according to the profit will be the 3, 5. Okay. In this way, we make the each nodes according to selection, and not selection will be there. Suppose we have selected this one 3, 5, and make the possible. There is no possible cases of the fourth case. We have selected already 3 and 5 will be there. Now we consider the weight, the second number weight. Now we have considering the third number 1 and 0. Either we have selected or not selected. Okay. So selection of the first weight will be the 1, and we are considering the third weight. That will mean to say we are adding the third number of weight, that 2 plus 4, that is called 6, and profit according to that 1 plus the third number weight profit is 5, that's why 6, 6. Okay. Now we are not considering the final weight. That mean to say the value will be the same previous one, 1 to 2. Okay, will we continue the same process? Either it will 6, 6, that is recommendable according to the weight we have selected, that is M 6, 7. Again same process will be continue for this one. Either we have selected or not selected. We have selected the second value. The profit will be the 2, and the weight will be the 3, and we have not selected, then 0, 0. Okay. Again we have selected the third value 1, and third value we have not selected. The profit will be the third one, that is called 2 plus 5, 7, and weight will be the 3, 4, 7. Now they exceeds the limit of the knapsack, that's why we cross that node. Now consider without selecting that value, it means to say the value will be the 2, weight number 2, that is your 2, and the previous one, that's why it's the same will be the 2, 4. Okay. Same case, we have selected or either not selected, will be taken either according to that. Now what we have to do, we make the bonding function, and bonding function will be limited as the case. Suppose we are taking the backtracking method. If we are not considering this one, go to the previous one. Again we are not considering this one, go to this one. Again we are not considering this one, go to the previous one. It means to say we are making the backtracking approach to solve this problem. That's why which solution is not proved by the case of this one, we will kill that node. If we are killing that this 7 node, and if there is a sometime anywhere node will be not selected, they can be killed. Now according to the state space tree we have designed, the profit we have considered, that is called 6. The maximum profit we have considered 6, and the 6 number weight is the proper arrangement according to the knapsack weight. So now we selected that value, which value gives the maximum profit, that value is the 6, 6. According to that, what is the value of x? Here we taking the path this one, we have selected the first value, that's why we have written 1. We have selected we not selected the second value, that's why we have written 0. Okay. And finally we have selected the third value, the x101. We mean to say, to maximize the profit, we selected the first weight and third weight to solve the Knapsack problem. So this is the maximum number of profit is 6, and the weight we have selected the value, that is called x1 is 1, x2 is 0, and x3 is 1. In this way, we can solve the problem, knapsack problem, by using backtracking method. There the various approaches will be considered, but in this way you can make the problem solutions, optimal problem solution will be given by the backtracking method. This is the for knapsack problem. Okay, thanks for this lecture.